Second class on geometry. I will start from one problem. So, just write down the problem. This is actually in IOQM 2020 problem. The problem is, let ABCD be a trapezium in which AB is parallel to CD, AB is parallel to CD, and AB is equal to 3 times CD. Okay, and let E be the midpoint of BD, and if this is the area, this mod symbol is actually area of ABCD is n times area of the triangle CDE, then what is the value of n? So, this is the problem. So, first try to understand the problem and then draw a figure. So, first draw this figure. So, ABCD is a trapezium in which AB is parallel to CD. So, this is AB. Okay, this is C. It's 3 times so the AB and CD, right? So, this AB is 3 times CD, so this AB is bigger and AB is parallel to CD. So, this symbol is for parallel, right? AB is parallel to CD, this was the symbol is for parallel, right? Two lines is parallel, like this one arrow or sometimes 2 arrows. So, now E is the midpoint of BD. So, this is D and you have to join D, B and D. And your E is the midpoint, somewhere E is the midpoint. Right. So, E is the midpoint and this triangles CDE, this is a triangle CD, and this area of this triangle CD, this n times of that is the area of the trapezium. So, can you find this? How do you find this? So, area of this the whole trapezium is n times this is smaller. So, n must be a number which is bigger than 1. So, how do you find this area? There are several areas theorem, right? What are the areas theorem? Trapezium, right? So, first of all, that the area of trapezium is half of what? Half. Sum of parallel sides. So, AB plus CD into, so height, some height is there. So, this height, this is perpendicular from D to AB, say n, so height is D. Now how do you map this area to the whole thing? So that is the idea. So you have to find the ratios of something. So what are the different formula for ratios of some areas of some triangles? So one theorem is, if there is a triangle like that and you divide this triangle in two parts, so ABC, and divide BC by D is some point, then you know that the area of ABD divided by area of ACD is actually BD by DC, right? Because the height is same. So area of two triangle, ratio of area of two triangles is just the ratio of the base. The one thing, and the other area also, if some that parallel lines, and if you have in the under the same parallel line you have two triangle, this triangle and say another is say this triangle, then again say these two are parallel, right? Then say A B C P Q R, and what is the ratio of these two triangle ABC and PQR is just BC is to QR, because the height is same. Now E is a midpoint. So since E is a midpoint, what is the relationship between the area of that CDE and that CBD? This is the full triangle. This is one triangle BCD, and this another triangle is CDE. So but this is a midpoint, right? So it is just half, right? So this, since is the midpoint, D is the midpoint, this is the midpoint, so this is equal to this. D is the midpoint of DC, so that means this triangle area and this triangle area is same. That means what? That means your area, that area CDE, area of this triangle CDE is half of the area of the triangle BCD, right? So we just lift this area to the bigger one. Now we have to find the relationship between that BCD and ABCD. Now this two parallel line, same parallel line, right? So what is the area of this BCD? Is actually half of, again it is half of what? Base into height. So CD into what is the height? This is the height. DN is the height, right? So this is the base, this is the vertex, apex. So this is the height. So this is DN. Now we can easily find from this. Now what is AB? AB is 3 times CD. That means what is the area of this trapezium? Half into, this is 3 times CD, so it is 4 times CD. 4 CD into DN, right? Right? So this is given. AB is 3 times CD. So it is 4 CD. Now you can easily find the ratio. Half of cancel, DN cancel, CD cancel, it is just 8, right? 8. So ABCD, area of ABCD divided by area of CDE is just 8. So N is equal to 8. Is it clear? Any question? You have any question? It's clear? Okay. So go to the next problem. Previous slide. Okay. Just write down this. Okay. You just draw the diagram and just write the hint thing. So details you can write in your home. Okay. Just write this part, this thing, this thing. This is a problem. So this part and this thing. Okay. Should I change the slide? So next problem is same IOQM at 2020 problem. Let ABCD be a rectangle. Now it is a rectangle in which AB plus CD plus BC is equal to 20, some 20 units, and that AE is equal to 9. Okay, where E is the midpoint. Midpoint of BC. Then find the area of the triangle, rectangle. So find the area of the rectangle. So for geometry, first you have to draw the diagram, right? ABCD, draw a rectangle ABCD, then take the midpoint and then try to find the area of ABCD using that fact that AB plus BC plus CD equal 20 and that AE equal to 9. So first draw the rectangle. So 90, all are 90 degree, and that AB plus BC plus CD is 20 and that E is the midpoint of BC. So take this midpoint E. So is the midpoint, that means B is equal to C and that A equal to 9. So how to find that? Is there any relationship between this 9 and the 20? What is the relation? Now this AB plus BC plus CD, but you know AB equal to CD, right? And that BC equal to twice BE. Then what is AB plus CD plus BC? You can replace CD by AB and you can replace BC by twice BE. Then it is what? From AB plus CD plus BC, what is this? BC is CD is AB, right? AB plus AB and BC is 2BE, then what do we get? Now this is 20. So since this is 20, what happened? What is AB plus BE? Right. So AB plus B is 10, but this is a 90 degree. Then we know AB square plus BE square is 9 square, right? Pythagoras theorem. So AB plus B is 10 and AB square plus B square is 9 square. Then from these two, what we get? What relation we get from this? These two relation. From these two, what we can conclude? You just square it. Square this AB plus B, square it. So it is AB plus B whole square equal to 100 and AB square plus B is equal to 81. Then right, 2 AB into B, right, B equal to 19. But what is 2B? 2B is BC. So it is AB into BC. So that is the area of the rectangle. Sorry. So this is actually the area. So area is 19. Clear? Actually we can't find this, need not to find this length of this two part. We didn't find the what is AB and what is BE. Okay, we can find, but no need. From two equation we can find that AB and what is BE. It's clear? So this is rather easy, right? The next problem is slightly hard. Should I change this? The problem is same 2020 problem. Let ABC be a triangle is isosceles triangle with AB equal to AC. Let D be a point on the segment BC such that BD is equal to 48 and 1 by 61. So don't go with this number, okay. Since this actually the in IOQM that answer is always a integer type, so from 00 to 99, that's why this type of number is given. Actually the answer will be some integer. If you give some easy number say 3, 5, then answer will be some root over or anything, maybe some root over, maybe point, fraction. So to give the answer in to find the answer in integer type, that's why this number is given. And DC is equal to 61. Now let E be a point on AD such that C is perpendicular to AD. And DE is 11. Then find A. Is E, okay. So This figure is slightly complicated and the problems are also slightly tough. So first draw the picture. First in geometry you have to first draw the picture. So what will be the picture? Triangle ABC, where AB is equal to AC. AB is equal to AC and let D be the point on the segment BC. This is the point on BC such that what happened? Some point is here. What is given to us? That DC is 61. So this number is slightly so we should write, say this is equal to, say B. Say B equal to 48 and 1 by 61. And that value is, say, A 61. Okay. No need of writing every time 61, 61, 61. That's why I write A. So this is A, this is B, right? DC is given, no, it's other way, right? We write A. This is A, this is B, right? That BD is A, right? Okay. Now what is E? Is a point on AD such that CE is the perpendicular, right? This is E, perpendicular to AD, and that ED is 11. This is 11. So and then you have to find A. So take this as X, right? Take some variable. Don't write every time A, B, C. It will take time or it will be some complicated. So write X, Y, Z. Then we should take this some number, right? So take this as Y. So let then what we have to take? Anything, any other line segment, or this will work? We can use Pythagoras here, right? So should I take this one as something H or something? C is 60 is given.
No, sorry, after calculating.
How it is 60?
D is given 11.
Yeah, this is 90 degree. So this is 90 degree. So C, so here C square plus 11 square is 61 square, right? By Pythagoras theorem. So from that C is 60. Is it 60? Yes, it is 60. Because 61 means 60 plus 1 whole square. So 60 square, 1 square plus 2 into 60. So 120 plus 1, 121. So, right. So C is 60, right? So we can write this as 60. This is 61. Then how to find X? To find X you need Y, right? X square plus 60 square is Y square. So one equation we have. So X square plus 3600 is y square. But again we have two variables, so we need one more equation, right?
From that BD square plus 11 plus x whole square, and we will equals that with the equation that you have written here.
But this is not the 90°. So that AD is not the perpendicular. So we need a perpendicular therefore, right? We can't use the Pythagoras in ABD. So we should drop a perpendicular now, right? So better drop a perpendicular from A to BC. Let this is N. Now N is the midpoint, right? Since it's isosceles triangle, N is the midpoint. So AN is perpendicular to BC. So that means BN is equal to NC. What is this? BN and NC is just A plus B by 2, right? No need of writing that 48 1 by 61 plus 61, so just write AB. What is DN now? What is DN? This is A, this is B, this is A plus B, so this is A plus B by 2. Now A plus B by 2 minus A. What is that? A plus B by 2 minus A? It is B minus A by 2. So it is B minus A. Now we have, so take this at the end as H, right? Say. Take this as H. We know AB, that AB is known. So we have one more variable, H. So actually we have three variables now, H, X and Y. AB is not variable. So we have already one equation here. So what are the other two equations? We need two more equations to solve this, right? Now we can use this Pythagoras theorem on here, on ADN, or on ADN. What is the value? What is the Pythagoras theorem? If you use, which relation we get? AD square, right? AD square means it is x plus 11 whole square is equal to that A minus B minus A, right? B minus A by 2 whole square plus A square, right? And one more equation we need. We can use Pythagoras in where? That in ABN. In ABN, what happened? Y square is equal to that A plus B by 2 whole square plus A square, right? Now we have three unknown, three equation. We have to eliminate H and Y, right? So then we find X. So how do we eliminate it? So first eliminate H. There is no H, so first eliminate H from here. How do you eliminate H? So subtract two equation. So find it. What is after eliminate H? What do we get? Is actually X plus, I say Y square is right first. So Y square minus X plus Y, X plus 11 whole square. Y square minus x plus 11 whole square, right? This minus this, so a square cancel out. Then a plus b whole square, a plus b by 2 whole square minus a b minus a by 2 whole square. What is the value? You know that? What is a plus b whole, a plus b by 2 whole square minus a minus b by 2 whole square, or b minus a by 2 whole square? It is ab, right? It is just a plus b whole square by 4, a minus b whole square by 4, b minus a or a minus the same thing. So it is a square minus b, a square plus b squares cancel out. So 2 plus 2ab minus 2ab, 4ab divided by 4. So it is just ab. So it is just ab, a into b. Now we have these two. Now what we have to eliminate? You have to eliminate. Now y you have to eliminate. So put the value of y here. If you put the value of y here, then what happen? What will get? So replace y square by x square plus 60 square, x square plus 3600 minus x plus 11 whole square is equal to a into b. X square cancel out and then 3600 minus 1 to 1, right, or to square 1 to 1 minus 22x, right, minus 22x is okay.
Can you explain that portion that you have written with it?
Here, oh, AB, we drop the perpendicular from A to BC and foot of the perpendicular is n. So AN is perpendicular to BC, and since this is isosceles triangle AB equal to AC, that it should be the midpoint. That means BN equal to CN or NC. Now this part is BD is A is just 48 plus 1 by 61, and DC is B, that is 61, and BC is then A plus B. That means your BN is A plus B by 2, half of that, because it is a midpoint. And then what is DN? DN is just, this is A plus B by 2 minus A. BD is A.
Yes.
So A plus B by 2 minus A is just B minus A by 2. So that is B minus A by 2. Oh, it is not H, sorry. AN is H, sorry. Right, there is a mistake. This is not H. And we took AN as H. Sorry. And drop the perpendicular from AN, that AN is H, not DN is H. DN is B minus A by 2. Okay. Now this is AB. What is A into B? What is this? 48 into 61 plus 1, right? So it is 48 into 61 plus 1 divided by 61, cancel out 61 61. So this is, so just calculate it. 48 into 61 is what? You just simplify the that calculation. You just take 1 here and 22 here. So it is 22x is equal to 3600 122, right? 1 and 21 and then 1 minus 1, 4861. So you have to just find these values. What?
9,
29
29. Final answer.
divided by 22, right? This 292, this 2, no, this is 2 some,
61, 69, 28.
then plus 122 and then subtract from 3600. Five 550, right? So it is 550 by, after dividing 2 no,
It's 25.
it's 25, right? So before dividing 22 it is 550. Okay. So it is a simple calculation, but is lengthy. It's just using the Pythagoras theorem. Okay. So now the next problem is again is 2020. Let ABC be a triangle with AB is equal to 5, AC is equal to 4 and BC is equal to 6. And the internal angle bisector, you know angle bisector, internal angle bisector of C intersect the side AB at D. Two points are taken. So, points M and N are taken on sides BC and AC respectively, such that DM is parallel to AC and DN is parallel to BC. If Mn square is P by Q, now P Q can be anything, right? It is not anything. Actually, if P say P1 Q2, then it may be 1 by 2, maybe 2 by 3. That is given that P and Q are relatively prime. You know relatively prime in the lowest term. GCD is 1. So the P and Q are in the lowest term or in the relatively prime. That means where P and Q are relatively prime, that means GCD is 1, or you can say it is in the lowest term. Prime and positive integer is positive also. Then you have to find something from is called in problem is sum of the digits of P my find the, this part is not important actually, find sum of digits of P minus mod of P minus Q. Okay. So this part is just for, actually you have to find P and Q basically. This part is for, because the answer is should be in from 00 to 99, that is why this is this type of thing. So it is actually maybe more than 99. So some P may be more than 90 and Q may be more than 90, and in that situation actually P is more than 100 in this problem. So that is why it is given that that is why they do not ask that find P minus Q. P minus Q also may be more than 100. So the answer must be in the form 2 digit 00 to 99. That is why this part is given. So this is not important, but the important is up to this. So again you have to draw the figure first. So what is the, draw this figure? AC, B, 6, 5, 4. ABC. AB is 5, AC is 4 and BC is 6, right? The internal angle bisector of C. So these two angles are equal, right? Say it's meet at some where? Oh, it is given. Is the intercept the side AB at D, it is D. Now next what? Point M on BC such that DM is parallel to AC, so it is parallel to this. So this is parallel line, right? This is parallel to this. Then this is M. Then DN is parallel to BC, N is on AC. This is N and this is parallel to this. DN is parallel to BC, right? And then you have to find MN, that part. So you know similarity, right? Similar triangle. And what is the relationship between two similar triangles?
That
No. Which two are similar?
sir,
Triangle
CDN
C CDN.
and CMD.
You say the same thing. CDN and CND. No.
CMD.
CMD.
Yes.
These two are similar. These two are congruent actually. These two are congruent.
Sir, ACB and AND.
Right. ABC and ADN. Because these two are parallel. Since this is parallel, the angle ADN is same as angle ABC and angle AND is same as angle ACB. Since these are parallel, therefore what is the symbol for similar triangle? Triangle ADN is similar. This is similarity. Angle ABC. And what are the other similar triangle? One more. BDM, right? So triangle BDM is similar to same thing, same triangle. Triangle BAC. Now we know that if two triangles are similar, then some ratio will be equal. Is ratio of area is sides are equal. The ratio of the sides are equal. The area is the square of the ratio of the area is the square of the ratio of the sides. Now no need of the area because here is nothing deals with area. So now it is what? Now it is AN by AC is same as AD by AB, which is same as ND by CD. So from there what we can conclude? Can I find this AN, CN, all these values? Oh, one more thing you have, that this is the, what is this? These two are equal. Do you know this angle bisector theorem? What is angle bisector theorem? You know angle bisector theorem? Okay, better I do in the next slide. The next slide. So what is angle bisector theorem? You know this? This is very important theorem in geometry. What is angle bisector theorem? You know this? No? This is very important theorem. say this is triangle ABC and we have this angle bisector of say A, these two are same angle, so this is D. Then angle bisector says that it is given that angle BAD is same as angle CAD, then what happen? If this is true, then the conclusion is AB divided by AC, that ratio of these two sides is same as ratio of the two base BD divided by DC. This is a very important. Do you know this? And this is by how we can prove it? Using similarity again. You know this proof? That you have to first extend this one and drop the perpendicular and drop a perpendicular to here, and then there are some similar triangles are there. One similar triangle is AB, this AM with this, these things, these two are equal, and other these two are also similar, that BND and CMD say. Now from that you can find BD by DC is actually your this divided by this, and again this divided by this is just this divided by this, because these two AD, say this is N, this is M, AD, ABN and AMCM is similar again, because two angles are equal, both are 90 degree, third angle must be equal. So from that we can easily find this. So go back with this. So then what happened? Then AD by BD is what? AD by BD? AC by BC. So 4:6, 2:3. That means this is 2, this is 3. Because sum is 5. So this is 2, this is 3, right? 4:6. So 2:3. Sum is 5. So 2 by 2. Actually it is 2 and 3. Just not 2:3. It is actually 2 and 3. So since this is 2 and 3, then by similarity, what are the other? What is CM? What is MB? And what is this AN? This is 2:3 and this whole thing is 4. So what is this part and this part? It must be 2:3 and sum is 4. So what is the two value? Find two number whose 2:3 ratio and sum is 4. One is 8 by 3, no, 8 by 5. You know that this ratio is 2:5. That means you have to find the sum of the ratios. You know the ratio proportion in your class 7 or 8. So it is 8:5. This part is 8 by 5 and this 12 by 5. The sum is 4. And from this 2:3, then this sum is 6. So what is BM and what is CM? So again it is 2:3 and sum is 6. Again same thing. Which by why? No, its sum is 6. No, sum is 6. So it is 2:3 ratio. Sum is 3.6. In what? This something by 5, something by 5. What by 5? So actually 30, total is 30 by 5. So 6 into 2, 6 and 3, 12 and 18. So it is 12 by 5. This is 18 by 5, right? So interestingly, what happened? CN is 12 by 5 and CM also 12 by 5. That means what? It is a square. Is it square? May not be square, maybe square, I don't know. Actually it is not square, because if it is a square then it is 90 degree, and if 90 degree then 4 square plus 6 square cannot be 5 square. So it is not 90 degree. So what is the value? These two are equal, right? So this is rhombus. So which one is rhombus? That the CMDN is a rhombus. Sorry, rhombus. Rhombus. Okay. What you have to find? You have to find Mn. And how do you find this Mn? Rhombus, that means Dm, Dn all are 12 by 5. Now this is slightly tough. You have to find Mn, right? Already you have one angle C is here, opposite is Mn, and again for a bigger triangle opposite is AB. You know AB, you have to find Mn, and already you know these two sides. Then do you know which type of theorem we can use? Actually, this problem is slightly higher level basically. The exam is actually for 9, 10 or 11, 12, but this is actually we need the cosine rule here. You know cosine rule? For a triangle cosine rule? You know cosine rule? If this side is A, this side is B, this angle is C, and this side is C, then what is the cosine rule? Cos C is equal to A square plus B square minus C square by 2AB. And if you use this cos C here, then what happens? One part cos C will give you what? 4 square plus 5 square minus, oh sorry, 4 square plus 6 square minus 5 square, right? Divided by 2 into 4 into 6. And if you use cosine rule here, then what happens? This cosine cos C is same as what? 12 by 5 whole square plus 12 by 5 whole square minus mn square, you got this mn, right? Divided by 2 into 12 by 5 into 12 by 5. Right? Now these two are same and you can easily find mn square. And the answer is actually 1, this p will be 126 and q will be 25. So it is 101. So that digit is 2, sum of the digit is 2, 101. Mn square will be 126 by 25 whole square, 25. Mn square is equal to 126 by 25. So you have to calculate all these things, just a simple calculation. Just find this and then okay. So this is simple arithmetic. Okay. So here is slightly tough in this for this reason that it have to use cosine rule. It's actually for class 9, 10 level, but still we have to use something cosine rule and sine rule. You know sine rule, cosine rule? Sine rule, sine A by sine A equal to B by sine B equal to C by sine A, and another is area rule. That area is half of AB into that sine C. Okay, we just write this all these formulas first. For a triangle, say drop the perpendicular and this is say A, B, C, and we symbolically we write BC as A, we write AC as B, opposite angle B and opposite angle C is AB is C. Okay, these are just standard notation. Now this angle is C. Now what is this H, height? What is sin theta here? Oh, sin C. H by B, right? H by B is sin C. So B equal to H sin C. H by B is sin C. So now what is area? Area is half of A into H. Sorry, it is H equal to B sin C. H by B equal to sin C, so H equal to B sin C. So area is half of A into H, so replace this. So it is AB by 2 into sin C, right? Similarly, we can, if we drop the perpendicular here from C, then what we find? Same area will be what? AC by 2 into sin B, and similarly, if we drop here, oh, this will get from C, since C's angle is there, so it is sin C. If we took this angle, then it is sin B, and if we drop perpendicular here, the other one, that BC by 2 sin A. Now all are equal, then what happen? So 2 will be cancelled out, AB sin C is same as AC sin B is BC sin A, and if we divide by ABC, then what happen? Divide by AC, sin C by C is sin B by B sin A by A. That's sine rule. You know how to find the cosine rule? You know? Actually using Pythagoras theorem basically. Do you know Heron's formula of area? What is it? Is delta is same as delta square is S into S minus. Did you ever prove this? Did you ever prove this formula? S is A plus B plus C by 2. You must prove at least once in your life. The proof is just again same. Actually, the main theorem, main definition for the area is half of the base into height. This is the main formula. So it is actually this, and the idea of proving that Heron's formula is you just take this as x and this is a minus x, and then use Pythagoras theorem. A square plus a minus x whole square equal to c square. A square plus x square equal to b square. Using Pythagoras theorem or other thing, you can eliminate that h, right? You can eliminate that h and x, and then you will find that area. Okay. So how do you find this cosine rule here now? Same idea, using Pythagoras theorem we can easily find the that cosine rule. Okay, there are others formula also like in circle. Do you know formula for in circle? In radius, delta equal to r into s. R is just in radius, and this is the easiest. I think it is the easiest formula and easiest proof. Why? You know the proof, right? For this, this is the center. So this is R. Everything is R, and we join this. So So this is A, then what is the area of this part, this thing, this triangle, half of A into R. Similarly this is half of B into R, and similarly this part is half of C into R. If we add this, half of R, take R common, A plus B plus C, so it is R into S. Okay. Before going into the next problem, I discuss on the problem which I state in the previous class. The problem is I give it to you for the homework. I will prove one result which is actually not true. You have to find the fallacy. You know fallacy? Fallacy, you know? You don't know fallacy, which is what is called fallacy? If I prove something which is not true, if I prove some 2 equal to 5 or 2 plus 3 equal to 9, then it is called fallacy. That means somewhere logic will be, some definition may be wrong, some logic will be wrong. You have to find whether the definition is wrong or logic will be wrong. You have to find the, no need of correct, okay. Don't correct it, don't correct my proof. Find the where the wrong is there, which part is wrong, this implies this is wrong, or some, if I use some result, say this result is wrong, right. Again I already told it in the previous class, till I just again I one more I quickly give this proof. I will show every scalene triangle is isosceles. You know scalene triangle? Scalene triangle? That ABC, say AB not equal to AC. It is given, but I will prove, we will show AB equal to AC. Can I show AB equal to AC? If I assume AB not equal to C, can I say AB equal to AC? No. But I will show it. That means something is wrong. Must be something in your school problem. Some 4 equal to 5. How do you prove 4 equal to 5? Divided by 0 basically. Dividing by 0, they show something, some tricky way they divide by 0. So some 4 into 0 equal to 5 into 0, then divide by 4, 0, 0, 0 cancel, 4 equal to 5. That is the fallacy. And you have to look at, no, you can't divide by this number x. They don't say it is 0. Say take x equal to 5, take y equal to 6, then x square. Somewhere is called like a x square minus y plus a. Somewhere it is y square. As an expression they are different, but actually both are 0. And divide by these two, we get the result 4 equal to 5. So actually dividing by 0. Here also same thing, same not divided by 0, but some argument, geometrical argument may be wrong. You have to find where it is wrong, goes wrong. So we will show this. That means it is a fallacy. The steps are, you must just observe steps. What are the steps? We first drop the perpendicular bisector. We just perpendicular bisector of this. Okay, quickly I just revisit this. This is the perpendicular bisector. Midpoint, N is a midpoint of BC and this is a perpendicular bisector. And we drop the angle bisector. These two angles are equal. And take this as I say G. This point is G. What is the G point? G point is the common point of angle bisector of A, BAC and the perpendicular bisector of BC. So that means GN is perpendicular to BC and AG is angle bisector of BAC. Okay. Always we can draw. You can ask me that it may be AG equal to AG may be same as GN. Yes, AG will be same as GN. AG means the line AG, not the length. The same, it will be same line. If it is same line, we have no intersection point. It is homework that if AB equal to AC, then the angle bisector is same as the perpendicular bisector. You know that. Angle bisector will be the same perpendicular bisector if it is isosceles triangle. But we assume that AB not equal to AC, so these are different. Right, okay. If AB equal to AC, then AGN are collinear. AC, then AGN are collinear. So no such G will be exist. Angle bisector and this perpendicular bisector both are equal. Which point will we take? we can't take any G, there is several G's,
Yes, sir.
right? We have to find the unique G, so it is not a unique, same line. You can say that okay, AG may be parallel to GN, then there is sorry, not AG is parallel to GN, angle bisector is parallel to perpendicular bisector, right? Again it is homework, if angle bisector is parallel to perpendicular bisector, actually they will be equal, same line, and
How can that angle bisector be parallel?
if AB equal to AC, that is the only case.
But
Okay. If two lines are equal, then we call it is parallel. Okay. It is by definition AB is parallel to AB.
it's parallel.
To AB. Same lines are equal parallel. Okay. The definition of parallel line is not, it's the two lines which never intersect is called parallel. That is a wrong definition. The definition of the parallel is the distance between two lines is same. If the distance between two lines is 0, then it is the same line. Now if AB equal to AC, then angle bisector and the perpendicular bisector are equal, same line. Then it is parallel. That is parallel, that means. So in that situation we can't find G, and this is if and only if it is scale in AB not equal to AC, we have a G, unique G, they will meet. You can easily prove that. Now we find G. Okay, in the next step, this is step 1, find G, not the find, this construct G, construct G. Next you join this. If we join this to BG and CG, what happens? Then these two triangles are congruent, right? Why? Using BGN and CGN. Congruent because of angle, side, common side, angle, side. So these two are congruent. Step 2. Triangle BGN is congruent to triangle CGN. And next you drop a perpendicular from G to AC. Drop perpendicular. Say this is P, this is Q. Again that A, step 3, the triangle APG is congruent to triangle AQG. Why? Two angles are equal. These two are right angle, one side, angle side, two angle, one side. That means what? That means this side is same as this side. Okay, already is angle bisectors, these two angles are equal, one side is common and one angle is equal, right angle. If two angles are equal, third angle also equal, all three, this is similar and one side is equal, that means congruent. And this side also equal to this side, right? Because they are congruent. Now what happens for these two triangles? Step 4. Triangle BPG and triangle CQG. These two are congruent. Why? Oh, since these two are congruent, we already have these two are equal. BG and CG are equal. Since these two triangles are equal, BG equal to CG, these two triangle are equal, congruent, PG equal to QG. Now for this two triangle, RHS, right? Two sides are equal, corresponding two sides are equal and two angle are 90 degree. Both are right angle triangle and hypotenuse are equal and one side is equal. RHS, using RHS these are congruent, right? Now since these are congruent, we already have what? This side is same as this side, right? So we already proved AP equal to AQ. Now we prove BP equal to QC. That means what? If we add these two, right? We already proved AP is equal to AQ and BP is equal to CQ. Then if we add AB is equal to AC. We prove it. Where goes wrong? Everything is okay, right? Is there anything wrong is with the that congruence formula? RHS, AS, SAS, everything is okay, right? One congruent formula is wrong, that is SSA. SSA is, it is wrong, but I didn't use SSA. I used SAS. I didn't use SSA. SSA is wrong. Actually, there are two triangle, two different triangle we can construct using SSA. I showed it in the previous class. You just go with the previous video, and you will find why this SSA is may not be congruent. But if there are three triangles are there with SSA, then two must be congruent. Three cannot be different. Two can be different, and one must be equal to one of them. Third one. So if you have say 100 many triangles, all follows this SSA. The side say 10, here side say 12, some angles, not the in between angle. If it is in between angle, then it is congruent. Some other angle say 30 degree, then the whole 100 triangles can will form two different groups. One group is congruent, another group is congruent. Here, actually, in the proof construction, everything is correct. The wrong is with the figure itself. The figure is not correct. This figure cannot happen, never happen. You can't draw this type of figure for any triangle, whatever the angle may be obtuse. No, it's not collinear. I told you. If AB equal to AC, then it is collinear. But if it is AB not equal to AC, then G, they are not they intersect. That we can prove. So actually the figure is wrong. This figure is not correct. Actually G will be the outside the triangle. Yeah, that is your homework. You have to show G cannot be inside. Whatever it is, it may be acute angle, it may be right angle, whatever, it may be obtuse angle. For every triangle, the intersection point is there, but is outside the triangle, not the inside the triangle. So the problem, actually the wrong with this figure. So go to your 9 or class 10 geometry books and check whether every figure is correct or not. Because if figure is not correct, then proof may be correct, but the ultimate result will be wrong. Or we can prove some result, which result is correct, but we start with the wrong figure, and there is some easier proof. Say the statement is correct, the theorem is correct, but we use a wrong figure and we get an easy proof. But that is, the proof is not correct because the figure is wrong. For with the actual figure, the proof will be tough. With the wrong figure, the proof is easy. So that you have to, that means you have to check the figure first, whether the figure is correct or not. But we didn't check that. No, we always check the whether proof is correct or not. We just recall the proof, we memorize the proof, but never ask whether it is the figure is correct or not. So here figure is wrong actually. You can't, you just draw using your compass and pencil, you will find that G will be outside, and G will on the circumcircle. That is the theorem. Actually, the theorem is like that. This angle bisector and perpendicular bisector will meet at on the circumference. This will be the G. This will be the correct figure. Is it okay? It is homework to you. So this figure is wrong. Now I will draw the correct figure now. Okay. You just write down this. Next slide I will draw the correct figure. Again, G cannot be the point N. Okay. That you can prove. Is outside the triangle. Actually the circle is every point other than 3 point, all other point outside the triangle, right? All other point, the inside cannot be any part of the circle inside the triangle. the whole circumcircle completely outside except this 3 point. Okay, should I with this next slide? So now we'll draw the correct figure. It's outside, right? This is a perpendicular bisector, this is angle bisector. We extend this, drop the perpendicular not on the AB is outside AB, right? Right? And BD equal to DC. Now again same part, we join this, join BG, CG, name this as P and Q. Now again these two triangles are congruent, right? BDG congruent to CDG, same logic. This two right angle, this is a common side, and this is BD equal to DC. So side angle side is not RHS, it is side angle side, right? So since these two are equal, what we have? We have BG equal to CG, right? Again we consider these two triangle AGP with the triangle AGQ. Again what happened? APG, AGP and AGQ. One is these two are right angle, two angles are equal, the common side, that means angle side. So these two are again congruent, right? And since these two are congruent, what happened? That this equal to this, right? This PG equal to QG, because these two are congruent, and the whole thing, the whole part equal to this whole part, right? AP equal to AQ, AP equal to AQ, because APG and AQG are congruent, right? Now consider the last triangle. Which triangle? This triangle, triangle BPG and triangle CQG. Why? Because BG equal to sides and one is RHS, right angle. They are also congruent. That means what? That means BP is same as CQ. So BP is same as CQ and AP is same as AQ. Subtract this, we have AB equal to AC again. See, point is inside, is wrong figure. Point must be outside. Whatever, it must be inside or outside. In both situations, AB equal to AC. Then this figure also wrong. Then G will be where? Outside or inside? He is correct. This figure is also wrong. Then what is the correct figure? It must be outside. But the thing is that this figure is also wrong. The actual figure you can draw using compass. You have to using compass, perfectly drawing, right? And you can see that you will see that one perpendicular will be outside the side and one will be the inside. Now you can't add or you can't subtract. Basically, say this is A, B, C, and say this is P, Q. Then AP is equal to AQ. This is correct because the proof is correct. And BP equal to CQ, that also correct. But your AC is this plus this, and your AB is this minus this. So that cannot be equal. Okay, so you can easily just draw using, you have to perfect drawing, you need a perfect drawing. Or you can do one thing, you just say very scalene. This is very bigger than. Actually, you can see that these two sides are very close to equal. That is why I can just manipulate this part. We can manipulate like something like say 5 and 1 or 6 and 1. So, we actually 6 plus 1 7 and this 6 minus 1 5. So, I want to actually show 5 equal to 7. One is 6 plus 1 is 6 minus 1, but somehow I put in the same or other same side or outside or inside, but one should be outside, one should be inside. But if it one side is 5 and one other side another side is say 15, then the manipulation we can't do. Then one is 10 plus 5 and this is 10 minus 5. So, that 5 part you can't show outside. So, take a this type of scalene, one side is very small, one is a big, and then just draw by hand also roughly this triangle you call roughly this, and then you can easily just right, this is the 90 and this is the 90 degree, you can easily check it, or you draw this using compass. Okay. So, this is very interesting result or thing. Why? Because sometimes the figure can be wrong, the proof is okay, every step of the proof is okay, the figure itself is wrong. So, you must check the figure every time. Okay. So, one more problem is this, again 202 problem. The sides of the sides x and y of a scalene triangle satisfy x plus 2 delta, delta is the area of the triangle, is equal to y plus 2 delta by y, what delta is the area, x is equal to 60 and y equal to 63, it is given. So, one side is 60, another side is 63, then what will be the largest side? What is the value of largest side of the triangle? Is this question clear? Is a scalene triangle, so 3 sides are unequal, and this 60 plus 2 delta by 60 is same as 63 by plus 2 delta by 63. Then what will be the value of largest side? One is 60, one is 60. So, you have to find the other one, third one. So, better you put here and find the delta. You put this, right? 60 plus 2 delta by 60 is same as 63 plus 2 delta by 63. Then what is the value of delta? Can you find the value of delta? You can easily find the delta. What? 2 delta by 60 minus 2 delta by 63 is equal to 3. Then 2 into 63 delta minus 2 into 60 delta is equal to 3 into 60 into 63. Then 6 delta, right? And what is delta? 31890. Okay, 1890. Then how do you find the third one? Largest side, value of the largest side. So one is 60, one side is 60, one side is 63, and the area is 1890. Can you find the third one? Yes, Heron's formula, but using Heron's formula is slightly tough, right? Because that third side will be in the 4, whole to the 4. That means 60 plus 63 plus x by 2 into 60 plus 63 minus x by 2, everything will be there then. So, can you just observe that anything is happening? Do you know what is height? So, this is very tricky actually. Actually, you see that 63 into 60 by 2, what is the value of that?
180.
What? 1890 actually. So, same. That means what? That means what? One side is 60, another side is 63, and the area is the product of these two sides by 2. That is the area. Then what is the meaning of that? What is the meaning of that? One side is, then what is the meaning of that? Correct, it is a right angle triangle. It must be a right angle triangle. If one side is x and another side is y and the area is x into y by 2, then must be right angle triangle. So, third side is just root over 60 square plus 63 square, that is the largest side. So, value of the largest side is just, you can just calculate what is value. Can you guess what is the value of this if it is an integer? It may not be integer, but since the answer is the integer type, that integer, it must be integer. So, can you guess without calculate this all 63 square and 60 square? You know that the result is will be integer, that we know. Then what will be the integer? 80.
Yes, sir.
18. No, it should be bigger. 80. It can be 80, because if it is a, the side is a z, then your z square is actually 60 square plus 63 square. So, guess it. 87. Something. The unit place must be 3 or 7, right? Because the unit place is 9. So, 1 square is 1, 2 square is 4, 3 square is 9, 7 square is also unit place 9, 5, 4, 6, 8, 9 square is just 1. So, it either 3 or 9. So, it is 7 or 3. So, it may be 67, maybe 73, maybe 77, maybe 83. So, you can just guess basically just 60. It actually it is bigger than say to this, right? Because 60 square is 3600, so it is bigger than that. So, since it is bigger than that, it can't goes beyond, it will goes after 80 now. 80 square is 6400, so it is go beyond 80. It should be less than 90, right? 90 square is 8100. So, it is not, it is obviously less than some 9000. So, it is 83 or maybe 87. Whatever, no need of I do not want to calculate all these things. So, Z must be bigger than 80 and less than 90, like that. So, I think it is 87, no, it is very close to 87, it is very close to that. So, 83 is not, 83 square will be not not exceed this thing. Which one? I do not know actually, you have to ask this. Can even go and just ask that it's not working. Okay. So, clear? The last one? Sorry, it is 0. So, this is the last one. The question is lengthy, but the answer is short. Let ABCD be a parallelogram. Okay. Gram. Let E and F be the midpoints of AB and BC respectively. The lines EC and FD lines EC and FD intersect in P and forms 4 triangles. APB, what are the 4 triangles? BPC, CPD and DPA. These are the 4 triangles. If the area of the parallelogram, that parallelogram area ABCD is square unit, you can write 100 also. What is the maximum area in square unit of the triangle among these 4? What is the maximum of these 4 areas? APB, area of BPC, area of CPD and area of DPA. What is the maximum value among these 4? This is the question in square unit. So, you have to find the number. So, first you have to draw the figure. Draw the figure. ABCD parallelogram. And then E and F be the midpoint of AB and BC. Midpoint is E, midpoint is F, right. The line EC and FD. AC and FD meet at P. This point is P. Three triangles are there, right? What are the three triangles? Sorry, four triangles. A, PB, BPC already there, CPD and DPA. The fourth triangle are there. So what is the maximum value of this? So total area is 100. Again, this is the area formula, right? Again, that same thing, same the first, like the first problem. Area of the triangle, the ratio of the two areas is ratio of size like that. So remember, this is the midpoint. Okay.
We have to means the ratio of the sides.
Okay, we first say take some numbers. Say the area of this APB is say x or x1. Area of BPC say x2. Area of CPD say x3, and area of DPA is say x4. So 4, and you have to find the largest value of x1, x2, x3, x4. So can we find the relationship between x1, x2, x3, x4 and the whole area, whole parallelogram 100 with the 100? What is the this is the midpoint, remember E is the midpoint. Then what is the area of this with the relationship with that APB?
Addition of x1
No. This area, that area of that BPE, what is the relationship with the area of ABP? Half of this, no? Because the midpoint. This EB is the half of AB. Same base, same vertex. That means area of EBP divided by area of ABP is just area of the length of EB by AB. So it is just right half. So it is half of this. So it is x1 by 2, right? Right. Then you know this area. This is x2, right? Then if you add x2 and this one, what happened? X1 by 2 plus x2, it is what? Is it 25? No. What is the area of ABC? Area of the 50. So area of the ABCD is just 100, and this is diagonal, and diagonal intersect, divide the whole parallelogram with the two congruent triangles. So this is 50, and since this is 50, this is 25 because half again. The area of ABC is 20, that means area of EBC is 25. So this is actually 25, right? Again similar type of thing. This area is x2, right? And this is x3. This area is x3. It is given as x3. We just take this is x3. Then x3 with what? This is the half of what? Only this part. Triangle CPF. CPF what? Triangle CPF is half of no ABC, it is BCP because it is a midpoint. So it is half of x2 by 2. So this part is x2 by 2, the smaller part, and this is x3, that means again what? Again x2 by 2 plus x3 is what? Again it is 25, no? Because it is actually that BCD is 50, whole is 100, BCD is half of this 100, and again FDC is half of BCD, so 25. We have equation 1, equation 2. Any other equation? You need 4 equations to find x1, x2, x3, x4. What are the other equation? Okay, you just draw a parallel line from here. And draw a parallel line through P parallel to AB and DC. Okay. Now this is a parallelogram. I give some name, some XY. Then ABYX is a parallelogram, and CDXY is also parallelogram. Now this is half of the area of the parallelogram. This is x1. ABP. The triangle area must be the half of the parallelogram area, right? For any parallelogram, if you take the same base and whatever the vertex may not be a diagonal. This is the area is the half of this area is half of the parallelogram area, right? Now this area APB x1 is half of this parallelogram, and this x3 is also half of CDXY. If we add this to x1 plus x3 is half of whole triangle, so it is 50, right? So x1 plus x3 is 50. Is it clear? Because this is area is half of this area is half of this area. If we add this to this plus this is take the half common, half of this plus this, so half of ABC D is 50. Similarly, area of BPC and area of APD sum. Okay. So that parallelogram ABCD Clear? So area ABP is half of area AXYB. Area CDP is half of area XYCD. That means area of APB plus area of CDP is half of the whole parallelogram area, that is 50. So one equation. Similar the other equation, x1 plus x3 is 50, and similarly x2 plus x4 is 50, and we got this other two equations. So go to the next page. Say what are the equation? X1 by 2, right, plus x2 is equal to 25, then x2 by 2 plus x3, right, is 25, then x1 plus x3 is 50, x1 x2 plus x4 is 50. Better we double it, so x1 plus 2x2 is 50 and x2 plus 2x3 is 50. So how do you find this? How do you find x1, x2, x3? Do you have to eliminate all the, you can eliminate, right, from this two, one, this and this, you can eliminate x1, so it is x3 minus 2x2. So x3 equal to, from these two, x3 is equal to 2x2, right, and from these two both are 50. So this x2 plus x4 is same as x2 plus 2x3. So x4 is equal to 2x3. Then now x3 equal to again 2x2. So x4 is same as 2x3, which is same as 4x2. Then how you find x1? x1 plus x2 plus x3 is 100 from these two, right? Okay. And then one more equation you need, right? How to find this x1? What is x1? x1 is 50 minus x3. So put something, some x2 equal to say, so replace everything in terms of x2 basically. So x3 is 2 times x2, replace everything in terms of x2. x4 is 4 times x2, and this x1 is what? x1 is 50 minus x3, and what is x3? x3 is 2 times x2, so 50 minus 2 times x2. So everything replace in terms of x2 and put it here. So this plus this plus this plus x2. So how many is that there? 6x2 minus 2, 4, 4x2 plus x2, 5x2. 5x2 plus 50 is 100. So x2 is 10 then. x2 10 means x3 is, no, x1, x3 is 20. So x4 is then 40 and this is 30. So 50 minus 20, 30. So highest is 40. Okay. Any question? So this type of question will be in this IOQM level. So some questions are easy using just area and just Pythagoras theorem, but one or two questions maybe you have to use the sine rule or cosine rule. Okay. So you need that is called the properties of triangle. Okay, so this is for today.
Thank you.
Thank you.